Welcome to this video. In this video, we shall discuss empirical formula and molecular formula. And under this topic, these are the things we are going to discuss. The first one is definition of what empirical formula and molecular formula. I'll be using EF for empirical formula and MF for molecular formula. The second thing, we shall look at the relationship between empirical formula and molecular formula. Then we shall look at when empirical formula can be the same to what molecular formula. Then we shall look at what can two compounds have the same empirical formula. The next one, how to determine empirical formula and molecular formula from percentage composition by mass. Then the sixth one, how to determine empirical and molecular formula from combustion analysis of compound. Then the last one, we shall look at what application of empirical formula in real life. Application of empirical formula in real life. Let's take the first one. Definitions of empirical formula. Empirical formula. Here. What is another name for empirical formula? It's known as pseudo formula. Take note. Pseudo formula. Empirical formula. This is the simplest number ratio of various elements present in one molecule of compound, present in one molecule of compound. That is what empirical formula. The simplest whole number ratio. The simplest whole number ratio you can get in one molecule of what compound. The simplest whole number ratio of all elements present in one atom, in one molecule rather, of a compound. The simplest whole number ratio of various elements present in one molecule of a compound. Let us look at molecular formula. Molecular formula, MF, which is also known as real formula. Real formula. This is the exact number of atoms present in one molecule of compound. One molecule of what? Compound. That is molecular formula. The exact number of atoms. The exact number of atoms present in one molecule of compound. It's not like empirical formula, which is a pseudo formula. This one is the simplest whole number ratio of various elements that can be found in one molecule of what? Of compound. Then let's look at what the second thing we are discussing. The second thing we shall discuss, which is relationship between empirical formula and molecular formula. The relationship between empirical formula and molecular formula. Let's look at relationship between empirical formula and molecular formula. When you have relationship between empirical formula and molecular formula. The relationship between empirical formula and molecular formula. The relationship is given as MF, which is molecular formula, equal to N times what? Empirical formula. Take note of this. Relationship between molecular formula and empirical formula is given as molecular formula equal to what? The number of ratio of molecular mass to what? Empirical mass times what? Empirical formula. What is N? Class. N is what? Ratio of molecular mass molecular mass, or you can say molecular weight, to empirical weight, empirical mass. N is the ratio of molecular mass to empirical mass. How do we say its ratio? If you make N the subject of the formula, what we are? We are molecular formula over empirical formula equal to what? N. Is the ratio of molecular formula or molecular mass to what? Empirical formula or empirical mass. Take note of that. Let's move further. Please, let's move further. Let's move further. Let's move further. From here, let me give you an example. If you have this compound, C6H12O6, which is what? Glucose. Glucose. This is what? Molecular formula of glucose. We can get the simplest whole number ratio of glucose. Look at, this is what? The actual number of carbon in what? Glucose. The actual number of hydrogen in glucose is 12. The actual number of oxygen in glucose is what? Glucose is what? 6. These are the actual number of what? Carbon, hydrogen, oxygen atom present in what? Glucose. That is why this is the real world formula of glucose, which is the molecular formula. The actual, this glucose has what? This number of atom of carbon present is what? 6. The number of atom of hydrogen present is 12. The number of oxygen atom present is what? 6. This is the actual what? Formula of what? Glucose. Then to get the empirical formula, get what? N from here. What do they have in common? They have 6 in common. That is what? My N, 6. Then what we have? That means 6 divided by 6 will give you 1. You have just 1 carbon. 12 divided by 6 will give you what? 2. You have 2 carbon, 2 hydrogen rather. Then 6 divided by what? 6, you have 1 oxygen. This is what? Empirical formula of what? Of glucose. Empirical formula of what? Glucose. The empirical formula of glucose is this. Take note of that. This is the empirical formula of glucose. The simplest whole number ratio. The simplest whole number ratio of carbon or glucose, 1:2:1. The simplest whole number ratio of glucose, 1:2:1, which is what? The empirical formula. The simplest whole number of various atoms in what? One molecule of a compound. That is this empirical formula of glucose. While this one is what? The actual, the exact number of what? Atoms present in what? Glucose. The actual number of what? Carbon atom in glucose is 6. The actual number of what? Hydrogen atom in glucose is 12. The actual number of oxygen atom in glucose is what? 6. While their simplest whole number ratio is what? 1:2:1. While their actual ratio is what? 6:12:6. The simplest one is what? 1:2:1. That is what? Empirical formula. And this is the relationship between what? Molecular formula and what? Empirical formula. I'm giving you the meaning of N. I say N is the ratio of what? Molecular formula to what? Empirical formula. Or the ratio of what? Molecular weight or molecular mass to what? To empirical weight or empirical what? Mass. Or empirical formula. Take note of that. Let's move further. That means I can simply say molecular weight. It's the same thing as N as what? Empirical weight. Take note of this formula. This is another formula of what? Another one expression that shows relationship between what? Molecular formula and what? Empirical formula. That means molecular weight equal to what? N multiplied by what? Empirical what? Weight. Please take note of that. Let's move further. Please, let's move further. Okay, if I give you this, look at this. If I give you C6H6, which is what? Benzene. benzene. This is what molecular formula of benzene. What is the empirical formula of benzene? What is the empirical formula? That means this is the actual number of carbon atom and hydrogen atom in one benzene. Then what is the empirical formula? The simplest whole number ratio of benzene. They have 6 in common. Bring that 6 out. 6, that is N. What do we have left? We have how many carbon will be left? We have 1 carbon, then 1 hydrogen. This is empirical formula for benzene. CH. Look at this. When you have hydrogen peroxide, molecular formula of hydrogen peroxide. What is empirical formula of hydrogen peroxide? The N here is what? 2. That is then how many hydrogen will be left? H. How many oxygen will be left? 1. That is 1 hydrogen, 1 oxygen. This is what empirical formula of what? Of hydrogen peroxide. Yn is what? 2. Please take note of that. Let me give you this one again. If you have this, look at this. Look at this. Let me give you C2H5OH. C2H5, okay, C2, C2 H5COOH. Or which one? Let me okay. This okay. Let me give you this. Okay. COOH. Let me give you this. Yeah. Let me give you this. This is ethanoic acid. Ethanoic acid. That means this ethanoic acid. This is ethanoic acid. Ethanoic acid. Ethanoic acid. This is the molecular formula of ethanoic acid. Then what is empirical formula of ethanoic acid? What is empirical formula of ethanoic acid? If you look at it, how many carbon do I have? I have 2 carbon. How many hydrogen do I have? This is 3 hydrogen plus another hydrogen here, making what? 4 hydrogen. Then how many oxygen do I have? 2 oxygen. 2 oxygen. Then that is molecular formula. Then how can we get the empirical formula? Simplify this. Take it to the simplest form. What do they have in common? What do they have in common? They have 2 in common. Bring it out. That is your N. Your N is 2. Then into 2 divided by 2, you have 1 carbon left. Then H, 4 divided by 2, you have 2. That means 2 hydrogen left. Oxygen, 2 divided by 2, you have 1 oxygen left. This is empirical formula of ethanoic acid. Empirical formula of ethanoic acid is this. While molecular formula of ethanoic acid is this. The ratio of molecular formula to empirical formula is 2, which is N. Take note of that. Then let us look at the next one. When can empirical formula be equal to molecular formula? When can empirical formula be equal to molecular formula? When can empirical formula be equal to molecular formula? When can empirical formula be equal to molecular formula? Empirical formula can be equal to molecular formula if the compound cannot be simplified any further. Take note. Empirical formula is equal to molecular formula. Is equal to molecular formula. Or I can say molecular formula is equal to empirical formula. If the molecule cannot be simplified any further. If a molecular compound, if a molecule of compound cannot be simplified any further, that means empirical formula will be equal to what? Molecular formula. When what? A molecule of compound or a compound cannot be simplified anywhere further, That means empirical formula and molecular formula are the same. An example, look at this. H2O. This is the simplest whole number ratio of H2O. That means you can't simplify this any further. Therefore, this is molecular formula of H2O. Therefore, the empirical formula is also what? H2O. Take note of that. When you have C12, H22, O11, this one cannot be simplified any further. This is molecular formula of sucrose. Therefore, the empirical formula is also what? C12, H22, O11. It cannot be simplified any further. They don't have anything in common. Carbon, hydrogen, oxygen. Three of them don't have what? Any number in common. The only number they have in common is what? 1. The only number they have in common is 1. I can simply say when n equal to 1, empirical formula is the same thing as what? Molecular formula. That's what it is. When n is equal to what? 1. When you have n to be equal to what? 1. That means when you have molecular formula equal to n times what? Empirical formula. When this n is equal to 1, that means molecular formula is the same thing as empirical formula. When the molecule of the compound cannot be simplified any further. This is what? Sucrose. Molecular formula. The empirical formula is the same thing. When you have ACl, hydrogen chloride, the empirical formula, the molecular formula is this. Therefore, the empirical formula is also what? ACl. 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 Take note of that. That means when n equal to what? 1, molecular formula is said to be equal to what? Empirical formula. Take note of that. Please take note of that. That means when the word molecule cannot be simplified any further. That means when n equal to what? 1. Molecular formula is the same thing as empirical formula. Let's go to the next one. Can two compounds have the same empirical formula? That is yes. Two compounds can have the same empirical formula. Or I can say, can different compounds have the same empirical formula? Yes. Let me say 2. Can different compounds, that one will be better. Can different compounds have the same empirical formula? Yes. You can have 2, 3, 4 compounds having the same empirical formula. Yes. That question came out 2015. You will see. They are going to use the question now from JUPEB. They say, which of the following pair of compounds have the same empirical formula? We can look at the question. Please don't forget to punch or press your subscribe button. Please share this video to your friends. If you need any physical class for JUPEB, JAMB, WAEC, there's a link below this video, a WhatsApp link. You can press it and join. And if you want to call, you can call for physical classes. If you need physical classes or online classes for JUPEB, JAMB, and WAEC. Your 300 and above is sure in JAMB, and your 3 A's is sure in JUPEB. Your 3 A's, your 3 distinctions are sure in JUPEB. For WAEC, you are covered. You are covered by neo-TISA. Neo-TISA. You are covered by neo-TISA. Please press subscribe button, share this video with your friend, comment, like, and so that we can give you more video, more video. This is where the concept is given. We are going to give you the concept in physics and chemistry, math, biology. Please, for more video, subscribe. Please, for physical class, for online class, private class, please, you see the WhatsApp link, press it, join the link. Then if you want to call, you can call any one of those 2 numbers, which are the word admin. Call any one of them. You are covered. May God be with you. Let's continue. Take note of that. Then let's look at number 4. I told you, empirical formula can be equal to molecular formula, or molecular formula can be equal to empirical formula if the compound or the molecule cannot be simplified any word further, or when n equal to what 1, empirical formula is the same thing as molecular formula. Can different compounds have the same empirical formula? Yes. Different compounds can have the same, empirical formula. Look at this, e.g. where you have ethanoic acid, CH3, COOH, ethanoic acid. I told you how many carbon do we have? 2. How many hydrogen? 3, 1, making what? 4. Then how many oxygen? 2. This is molecular formula of what? Ethanoic acid. I told you this is ethanoic acid. Yeah, ethanoic acid. What is the empirical formula of this ethanoic acid? Please, what is the empirical formula of ethanoic acid? What do they have in common? They have 2 in common. Bring it up. That means the N is 2. I have what? They have 2 in common. That is N. They have 2 in common. Then, what are we going to have left in the what? Empirical formula? This is C2 divided by 2. We give you what? C. H4 divided by 2. We give you what? H2. Then O2 divided by 2. We give you what? O. This is empirical formula of what? Ethanoic acid. This can have the same empirical formula as glucose. Look at glucose. Glucose is what? C6, H what? R12, O6. This is molecular formula of glucose. What do they have in common? They have what? 6 in what? In common. They have 6 in what? In common. Then, what will be the empirical formula? That is the N is 6. What is the empirical formula? 6 is divided by 6 will give you what? Just 1 C. H12 divided by 6 will give you what? H2. That means 12 divided by 6 will give you 2. That means H2. Then O6, that means 6 divided by 6 will give you what? O. That means this is empirical formula of what? Of glucose. That means glucose and what? And glucose and what? Ethanoic. They have the same empirical formula. Yes? 2 or more compounds can have the same empirical formula. 2 or more compounds can have the same empirical formula. 2 or more compounds can have the same empirical formula. Let's look at the one that came out in JUPEB 2015. JUPEB 2015. JUPEB 2015. JUPEB 2015. JUPEB question 2015. Let us look at a question that came out in JUPEB 2015. JUPEB 2015. The question says, identify a pair of compounds with the same empirical formula in the option below. Question 1. Identify a pair of compound. A pair of compound with the same empirical formula in the option below. In the option below. Identify a pair of compound with the same empirical formula in the option below. Identify a pair of compounds with the same empirical formula in the option below. Option A, we have C3H6 and C4H10. Option B, we have NO2 and N2O. Option C, we have C2, H2 and C2H6. Option D, we have P4H10 and P2H5. P2H5. Let me say change this one to N2O5. Let me change this one to N2O5. Please. They say identify a pair of compounds with the same empirical formula. That means with the same empirical formula. Identify. You can pause the video and do it. It's very simple. Look at what C3H6 and what C4H10. In this case, this one, what is common to 6 and 3 is what? 2. That means we are going to add for this one, 3 rather. To C3H6, what is common to them is 3. That means we have what C and what H2 left. Look at this one. What is common to them is what? 1. Take note, empirical formula cannot be in decimal number. Cannot be in fraction. Empirical formula cannot be in what? Fraction. It's a simplest whole number ratio. Simplest whole number. Take note of that. It's a simplest whole number ratio. It cannot be in fraction or decimal. If you work a question, you see a question that I will give to you. We are going to have what? A fraction or a decimal number. You have to multiply it, convert it to what? Whole number. Empirical formula cannot be in what? Decimal number or fraction. It can only be in what? Whole number. That's why they say simplest whole number ratio. Take note of that. That means, in this case, what is common to C and H is 1. That means the empirical formula of this one molecular formula, empirical formula. For this one, molecular formula, the empirical formula of this one is common. That means you see have C4H10. That means they are not, their empirical formula is not the same. That means option A, wrong. Let's look at option B. Let's look at option B. Option B, where you have NO2 molecular formula. In this case, the N is what? 1. Therefore, empirical formula is what? Is NO2. 1 is common. N2O5 molecular formula. What is common to what? N2O5. It's the same one. Therefore, the molecular formula is the same thing as empirical formula in this case. That means the empirical formula is not the same. It can never be the answer. Look at option C. Let's look at option C. Let's look at option C. There you have C2H2. C2H2. That is what? Ethyne. C2H2. Ethyne. In this case, what is this is molecular formula. Equal the N. What is common to us? C2H2 is what? 2. Bring it out. The N is what? 2. What are you going to have there? C2 divided by 2 will give you C. H2 divided by 2 will give you H. Then let's look at what? The pair given. C2H6 equal to, what is common to them? I'm sorry, is C3. Is C3. I'm sorry, the option is C3. C3. This one is C2H, I'm sorry, C6. Is 6 The option is 6 H6. I'm sorry. This one is C2H2. That one is C6H6. Okay, let's look at it. C6H6. C6H6. In this case, what do they have in common? They have 6. That means 6 divided by 6, you have C. Then H6 divided by 6, you have what? H there. That means the empirical formula of ethyne is what? CH. The empirical formula of benzene is what? CH. That means ethyne and benzene, they have the same word empirical formula. Ethyne and benzene, they have the same empirical formula. I'm sorry, the option is for C2H2 and C6H6. That means ethyne and benzene, they have the same empirical formula. Therefore, the correct answer to this option, to this question rather, the correct option to this question is what? Option C. Take note, option C. Please, for this two, it will be another video, which will be what? Under this video, in the link below. After this video, you will see a link. It will be for these two. Please, these two are very important. Please subscribe, please share, comment, like. And if you need any physical class, please, or online class, you see a WhatsApp link below. Please, you can press and join the group. You can call any one of those two numbers as admin. May God bless you. Thank you.